Exponential functions occur in calculating compound interest. Let's go ahead and write down a few different things first. Let P be the amount of money invested. Let I be the interest rate on this amount, and this is per time period. Then, after one time period, the interest is given by PI. Therefore, the total amount of money obtained after this time period is given by, let's say, A, which is equal to our principal plus our interest. In general, we could keep reinvesting this amount over and over again. So for example, if we reinvested once, then the new principal is given by P plus PI. And then after another time period, the new amount would be equal to P times 1 plus I raised to the second. And in general, we can follow this pattern. After k periods, the amount is going to be given by P times 1 plus I, which is raised to the k. And the thing to notice is that we can represent this as an exponential, where we have 1 plus I is the base of our exponential. And we can express this in a more concise formula called the compound interest formula. Compound interest is calculated as follows. Again, we'll have A of t is equal to the following, where A of t is going to be the amount after t years, P is the principal, R is the interest rate per time unit, N is the number of times interest is compounded per year, and T is the number of time units. Now, an interesting thing about compound interest is this is one way we can derive the natural number E. So let's go ahead and suppose that we have an interest rate of 100%, and we'll also suppose that we're only looking at a time unit of 1. So the equation that we'll be looking at will be the following. Then let's go ahead and look at a few different values when we plug in a few different n's into 1 plus 1 over n raised to the n. We'll plug in 1, 10, 100, 1,000, and 1,000,000. Plugging in 1, we'll get the following. Plugging in 10, we'll get the following. And continuing on, we'll get the remaining following numbers. Now simplifying each of these become 2, then approximately 2.59, then approximately 2.704, then approximately 2.716, and finally about 2.718. And what we notice is that as n approaches infinity, our value of 1 plus 1 over n raised to the n is approaching 2.718. And we define the number E then as follows. This is the number defined to be the convergence of 1 plus 1 over n raised to the n as we have the values of n approaching infinity. And again, approximately the natural number E is equal to 2.718, so on and so forth. We'll look at one more problem in this section, and the idea is that given 2 points on an exponential function, we want to find the equation of such a function. So given the points 1, 3, and 2, 4.5, we want to find the equation of the exponential that goes through these 2 points. So first, let's go ahead and just rewrite the definition of an exponential. This is going to be f of x is a times b to the x. And we can go ahead and plug in what we know. So number 1, we know 2 points, and so we know each of these points are going to solve the equation given by our f of x here. So if we evaluate f at 1, we'll get 3 is equal to a times b raised to the 1. And if we evaluate our f of x at 2, we'll get 4.5 is equal to a times b raised to the second. Now divide this equation on both sides by a, and we'll get 3 divided by a is equal to b. And we can plug in this to this b over here. And we'll get 4.5 is equal to a times 3 divided by a raised to the second. And this simplifies to be a times 9 divided by a squared, which simplifies to be 9 divided by a. So this is a little hard to see, but let me go ahead and rewrite this equation. what we have is 4.5 is equal to 9 divided by a. Then multiply both sides by a and divide by 4.5. And what we see is that the letter a is equal to 9 divided by 4.5, which is equal to 2. So plugging in a is equal to 2 into our first equation again, we'll get 3 is equal to 2 times b, which means that b is going to be equal to 1.5. So we have our b, we have our a, and we just plug this into the general equation, and the solution that we're going to get is that f of x is equal to 2 times 1.5 raised to the x.